Hi everybody, and welcome to this week's episode of Beachcombers. My name's Emily and this is Jillian, and we're from the Whale Interpretive Center. This week we're going to be teaching you about tides. I think a lot of people don't understand tides and go to the beach and it's high tide or low tide and it's just kind of the way it is and no one stops to think why. So this week we're going to be telling you all about it.
So, as we mentioned last week, here we are on the traditional territory of the Snuneymuxw First Nation, and the core competency that we are talking about this week that follows the BC education curriculum is questioning and investigating from the thinking core competency.
So you'll notice this week we're going to be jumping around a little bit, and of course different tides happen at different times during the day, so that means we had to be filming over different times today and yesterday to kind of get to be able to show you all the different tides that we have here. So you'll notice that sometimes different video parts look like they're from different times, and that's just because we have to do that in order to teach you about the tides. You'll also notice that this week we brought in some drawn diagrams. Please note, we are interpreters, not artists, but we thought that that would be really helpful because some of these concepts of how tides work are actually a little bit confusing, a little bit mind-boggling, so we thought we'd bring in some diagrams to show you all about it. And so without further ado, let's head to the beach. So this is the difference between spring tides and neap tides. So this week we're using some diagrams to try and help understand some of these really complex theories. So when we get really big tides, we call them spring tides. And this is when the Earth, the Moon, and the Sun are in one line. And that means the gravitational force, indicated by these red lines, are all pulling together, which makes really big tides. Neap tides are what we call small tides, and this means the sun's gravitational force and the moon's gravitational force are pulling in opposite ways, which means they minimize each other's effect on the tides and therefore result in smaller tides. So what do you think about when you think about tides? You probably think about the water level going up and down the beach. So here we are interpreters, not artists, as you can see, but the water would go up the beach to the high tide line where the grass would start to grow and then go back down. But what is actually happening is this. The Earth is rotating and the tide is being pulled around the Earth in one giant wave. And as the Earth rotates and the moon pulls the water a certain way, that means that the Earth rotates into that essentially bulge of water, and that is what happens here. So it's not up and down, it's actually around. So we talked about how it's not actually that the water goes up and down, that it goes around, and you can see here. So every 24 hours, this is what happens. You've got a point here where the water bulges out based on the moon and sun's gravitational pulls. This means that there's two areas in the world at any given time that are high tides and two areas that are low tides. And then as the Earth rotates, different parts of the land go through different parts of the water, either high or low, and that gives us the tides. So here's that last diagram in a different way. So here we've got the moon, and here you've got gravity. And gravity is being pulled from the Earth and to the Earth from the moon, and that gives us this bulge of water. And you can see the side of the Earth that is closer to the moon has a stronger gravitational pull because it's closer to the moon, so it gets a bigger pull, so you kind of get an egg-shaped here. You still get some pull over here, but it's not as much, and you get less on the sides of the Earth because that water shifted forward. This means, again, here's our 2 points of low tide, 2 points of high tide, and as the Earth rotates, it goes through these different points, and it's because of the moon and partially the sun. What makes this complicated is, as you can see here, that depending where you are in the world, you get different tides. So if you're near the equator, you're going to get less tidal action, and if you're near the poles, you're going to get more. It also changes throughout the months because the moon is also moving and the Earth is moving in relation to the sun and the moon. So there's a lot of moving parts here, and that's what makes tides complicated to understand. So we mentioned that at the Earth's equator, there's less tidal movement than at the Earth poles. And the Earth's equator is almost like, imagine the Earth is wearing a belt. It's an invisible line that goes around the middle of the Earth. And this is where the tidal action is the least. So for example, we have the Bay of Fundy, which is actually located in eastern Canada, and this is where we have the biggest tidal action in the world. Tides can be bigger than 13 meters, and so that means at high tide, here's our boat in relation to the land, and at low tide we get a huge difference. Now if you got off this boat, you'd have to climb all the way up to get to the green part of the island. But in somewhere like the Caribbean, in a tropical area where there's very low tidal action, you see there is a little bit of a change, but hardly anything. 1 meter would be a huge tidal change in this area. In fact, the average tidal change is about 20 centimeters.
Alright, so I'm down in the lagoon right now. I'm just looking out towards the main part of the lagoon, and I picked this spot to do some filming because it really shows the change in tides. You can see this white line that goes all along the rock here. That's a tide line. That's how high the water gets. So if it was high tide right now, the vast majority of my body, up to right around my eyes, would be underwater, which is just crazy how much water moves in and out as a result of the tides and currents that work in this lagoon. So this is another example of those tide lines. This one is made up almost entirely of seaweed. Here's some of that rockweed we talked about. There's some dried twigs, a whole bunch of different species in here. But this is a really clear example of where the tide comes up to. Behind me is Shack Island, which anyone from Nanaimo will know. And so this shows just how high the tide will get, because this is the high tide line. This is how far the water is coming in every single day. Alright, so please excuse my hair. It's a little windier out here than I thought, and I do not have a hair elastic. So yeah, sorry about that. I'm here at the opening to Piper's Lagoon, and you can see behind me how there's just a thin opening where the water is. We call this a bit of a bottleneck effect, where a lot of water comes through here very fast. It's all trying to get through, and so it ends up moving a lot faster than it would otherwise if this was a bigger open space. This means that when the tide is coming in or out, when all this water is rushing through, there's a really strong current going through here. So this is the deep part of the lagoon. So you can see this is the first part to fill. It's the lowest part, so the water fills this first. So as I'm standing here, I can feel the current on my legs, and it actually is a little bit difficult to stand against, but it will get much harder. My coworker and I have been here times when we've been at our waist and we can barely stay standing without the tide swooshing us downstream. The water is lovely today, actually. It's very nice. This is a little bit of a difference from our normal work uniform. Thanks for joining us here today to learn all about tides. So here I am a few hours later, and as you can see behind me, the lagoon is now very full. And so the tide has been coming in over the last few hours. We are almost at high tide so far. It's about I think about 7:30 now, and high tide will be at 8:45, so it will continue to rise a little bit more. What I wanted to take an opportunity to show you now is just how high this tide gets. So you saw how low it was this morning, and now as you can see, the lagoon is completely full right up to that high tide line right there, right up to the grass here. And so because it is a full moon either tonight or within a few days, this means that the tides are going to be at their most extreme. There's going to be the highest highs and the lowest lows. And so we're going to see some really big changes. When we're right in the middle of the lunar cycle, we're going to see some calmer, less dramatic tides. Tides that don't get really drained and don't fill up nearly as much. And so yeah, I just wanted to take a chance to show you just how full everything is today. All this water that has come in a matter of hours. It's really amazing. If we were back over at the rocks where we were earlier, you would be able to see that we are right up to that white line.
Paul, we're gonna learn about some tides. Are what we're gonna do.